Welcome to another video on my Raspberry Pi 1 running Raspbian Linux and connected to Raspberry Pi camera, serial cable connected to the Serial Pi Plus board, which is stacked on the Raspberry Pi, and network cable which makes sure that I can use VNC, virtual network computing, as well as a band cable which is connected to this breadboard with some electronics and some fischertechnik stuff as well, which is also electronics. The focus is on I2C, for which I have installed this MCP 23008 chip. Via the GPIO I am using I2C lines towards the chip, and the program that I run now is using the wiring Pi as well as the GPIO stuff, controlling these LEDs for binary counter, and by lack of space this is the 8th LED, where to reverse the counting I use this switch and this LED, a tricolor LED, to indicate that it's been signaled. Out of scope for now is this part, using the SPI protocol with these wires. For this part there is another video series which I completed in the past. Some troubles that I have with this circuit is the fragile wiring here, and also the counting. For some reason it just stops working, and then without touching this there are problems working. So hopefully it works this time. Explanation for the probes. This is the, let me check to be sure, this is the clock and this is for the data, and the original algorithm was counting up to 256. I reduced it to 3, actually 8 because I have 3 LEDs, and in total, well, 0 is all off, 8 is this one, this LED, 3 LEDs on is 7, but since 0 is counting as well, I have 8 numbers. So let's see if it still works. And yes, it works. So with that I'm more than happy. And 0 and 7, 6, 5, 4, 3, 2, 1, 0. 2, 3, 4, 5, 6 and 7 and back to 0. And last time it was proven or shown that if I press the switch during counting, it won't reverse until it has completely counted the whole way. So let's see if we can change something. You never know. So with the signals from the I2C clock and data and the first two LEDs, the point is now how to proceed. The idea is to add more LEDs, and so I have to increase either of those, and I just have to increase these ones. So changing the digits, this will be cursor on the right place, of course. 4 digits is 2 to the power 4, 16. So this should be 15, and this will be going down from not here, here. So this one goes to 16. Time to interrupt this one and compile. Goes right as expected and run. And then see how things go. And it seems that everything goes well, although it will take a lot longer now. Well, countdown from 16 is not that hard. And now counting up to 16. Which goes well. And start again. Now of course these signals are not all visible on the oscilloscope. Only the first two, but you can see on the camera right here 5, 6 and 7. Oh no, because this one is burning as well, so this works reasonably well. And I can let go, and now what will we do? Yeah, it will finish the count up to 16. And countdown. And that's exactly what I wanted to show. Now this is of course a slow count. The original one went very fast. I can do that, but what's the fun of that? So now this binary counter works. Including, because that's of course part of the deal, Pi GPIO and MC and wiring Pi. So these three libraries are needed. these three to get everything working. And I can of course go back to the demo, the other one, which I haven't tried for quite a while. This one, because what was this one doing again? And now I should start this. Yep, demo is just LEDs after another. And if I click then, it goes the other way. And here you can clearly see that this LED is running. And this one is now, without the switch, is running, burning very short. And you can also see that this one is a three-color LED as well. So now effectively everything works. I have not. I don't have the code up for the demo, but that is no problem. Something that is worthwhile noticing is, of course, that here is up to 16 and here is from 15, and both are of course 16 large. So what can be done next? Right, one thing is of course that now this works. I can test everything, well, not everything, but most, in a much higher, somewhat higher speed. And let's just try all the way. So this actually means that this remnant of the whole thing will be now 256. So I will use everything. Then this one is will be slightly. Oh wait, this is different. Why is this one then the same 256 as the other one? Oh right, because here larger than 0 is used, and here I am using larger than and equal to 0. So I will remove this one, the equal to. Then here okay, now it is the same, everything, with use of all LEDs, if alright. So compile, correct, wiring, go. Oh wait, I'm still using the very slow version, so let me change that one. This delay can be changed into, let's say, half a second. And this one of course as well. Then so we don't have to wait for such a long time. And now see if it works. And you will see all LEDs. Oh wait, yeah, you can. Now you can see the red LED as well. And there goes the 8th LED. Fragile connection, unfortunately, apparently. Repair on the spot. Carefully. Alright, done. And now if I press this one now, because it's still counting down, and now it's almost done. No, it's still not almost done. One LED is still burning. Yeah, right, of course. So and now the whole counting down sequence was finished. Now it starts counting up. And I'll let it go. And it keeps continuing. As if it has a memory. And now the question is, of course, can I possibly interrupt it without this? That it starts counting up in the middle of the process. Of course, a change of algorithm. But anyway, I'm happy that everything works now. And well, this was how to control things and also how to read things. And now the big question is, to read things I had to use the Pi GPIO. But can I do it without? Can I do it without it? Can you use the wiring Pi? That's a very big question. And I don't think so. Two different libraries doing two different things. Alright, so now I have this view still working. And you can see here with quite a bit of delay that things are counting down, and they are up to right here. So you can see here an LED, here an LED, and here, and the rest is rather vague. So you can see the shimmering of the LEDs. And this one, of course, being the 8th LED. So that's working nice. Unfortunately, as said, with delay. And then this is full schematics with probes on clock and data, as well as the first two resistors to signal high or low. Can I do more? I would like to read more, but it will be in the same idea. Using the GPIO and then do what? Who knows? And I think for now this is a nice end. And with the countdown still running, thank you for watching. If you like this video, please subscribe to my channel, give the video a thumbs up, leave a comment or suggestion. There is a lot possible with I2C. You can also follow me on Twitter and Instagram, and please make a small donation as an appreciation for video and blog. You can also become a patron and have your name mentioned. Your name will be mentioned on my website, and depending on your pledge, also with my video in one or more ways. Everything you can see, watch again under this video. URL of my website as well for much more videos, etc. See also my YouTube channel, of course. For now, thanks for watching. Probably to be continued, and bye bye.